Hello. Today we're going to take a look at section 1.4, complex numbers. We're going to begin with the imaginary unit I. And the imaginary unit I is defined as I equals the square root of -1 where I squared equals -1. Now the imaginary unit comes in because, as you know, if we try to take the square root of a negative number and we put that in the calculator, we're going to get an error. And it's going to be an error because whenever you square something, whether it's a positive or a negative number, you will always get a positive result. So the imaginary number came in because whenever we have a negative under an even root, you're going to get an imaginary number. And we'll look more into what the imaginary numbers mean as we go through section 1.5. We're just going to introduce what an imaginary unit is in this section. So let's say that we have the square root of -25. Now, since we have a negative under the radical, the square root sign, we have to make sure that we bring the negative out by notating that it is an imaginary number. So the negative needs to immediately come out and become an I. And all that I means is this is imaginary. Now we could take the square root of 25, and the square root of 25 is 5, and don't forget the I. So 5i. The square root of a -25 would be 5i. Now, we are going to add and subtract imaginary numbers. And I always say something corny like, keep the real numbers with the real numbers and the imaginary unit numbers together. But I always say, real go with real, fake go with fake. So the real numbers, you combine those. The imaginary numbers need to be combined. So whenever you're adding and subtracting, complex numbers, and we have, say, A plus BI plus C plus DI equals, you add the two real numbers, A plus C plus BI plus DI. Now notice that whenever we write a complex number, that the real number appears first and the imaginary number appears second. And this is very important. The real number should appear first and the imaginary unit should appear last. And if we're subtracting, we have A plus BI minus C plus DI. And that simply means that we subtract the two real numbers, A minus C, plus, and subtract the imaginary numbers, BI minus DI. All right? Now let's put it into play. Let's say that we have 5 minus 11i plus 7 plus 4i, and we want to add those two together. And then our second problem, let's say that we have negative 5 plus I minus negative 11 minus 6i. So in A, we're going to look at the real numbers, and the real numbers are 5 and 7. So we're going to add 5 plus 7, and we get 12. And then we have to add the imaginary numbers. And negative 11 plus positive 4 is minus 7i. So when we add 5 minus 11i to 7 plus 4i, we get 12 minus 7i. Now, if we look at B, notice that we have negative 5 and minus a negative 11. So we combine the real numbers first, and negative 5 minus a negative 11 is the same as saying negative 5 plus 11, and we get 6. And then we have I minus negative 6i, and I plus 6i is 7i's. Now that's when we're adding and subtracting complex numbers. But what about when we multiply them? And when we multiply them, we may have to bring this definition where I equals negative the square root of negative 1, or I squared equals negative 1. We may have to bring that into place now. So let's look at when we multiply complex numbers. And we're going to multiply just like we will multiply any other numbers. So in A, let's say that we have 4i times 3 minus 5i. And let's say in B we have 7 minus 3i times negative 2 minus 5i. All right, so if we look right off the back in A, notice that we have the distributive property. So we have to distribute 4i inside the parentheses, and we get 12i minus 20i squared. Whenever we see an I squared, that is not simplified. I squared is equal to negative 1. So anywhere you see an I squared, you have to change it to negative 1 because that's the simplification. So we have 12i minus 20 times negative 1, and we have 12i plus 20, but we're not done because real has to be first. And so our answer would be 20 plus 12i. Real before imaginary. Now if we take a look at B, we have 7 minus 3i times negative 2 minus 5i. So some people do the box method, some people use the FOIL method. Whichever method is comfortable to you, that's the method I want you to use. But I'm going to use the distributive property, which is the FOIL method. And I have to take the 7 and multiply it times everything in the parentheses first. And so I'll do 7 times -2, and we get -14. We have 7 times -5i, and we get -35i. Now I have to give -3i to everything in the parentheses, and we have -3i times -2, we get +6i, and we have -3i times -5i, and we get +15i squared. Now it's a couple of things going on this line. We have where we could combine like terms because these two are playing on the same team, -35i and +6i. And we also have this I squared that needs to be changed to a, you got it, -1. So I'm going to rewrite this -14 minus 29i, because I'm combining like terms, plus 15, and instead of writing I squared, we write -1. And I simplify this to -14 minus 29i minus 15. And when we combine like terms, -14, -15, we get -29 minus 29i. Make sure your real number appears first. Okay? Now that's when we multiply. Now we're going to bring in a word called conjugate. And I'm going to give you the definition of a conjugate of a complex number. Now the reason we use conjugates in math, we don't like the I to appear in a denominator position. So since we don't like an I to appear in a denominator position because it's not simplified, we don't like that, we come up with the conjugate of a complex number. And I'm sorry, y'all can't get this whole thing on the screen. And so what that simply means is the complex conjugate number a plus bi is a minus bi. And the complex conjugate number for a minus bi is a plus bi. Now, whenever you take a complex conjugate and you multiply them together, say we have a plus bi times a minus bi, we get a squared plus b squared. You're going to get a real number once you multiply the conjugates, which hence gets rid of the I in the denominator position, because we don't want the imaginary number to appear in the denominator position. And if we have a minus bi times a plus bi, we still get a squared plus b squared. So our whole purpose is to get a real number in a denominator position. So let's see what Ms. Reese is talking about. Let's say that we have 3i divided by 4 plus I. Now let's take a look at the denominator. That denominator has an I. We can't have it right there, so what we have to do is look at the denominator, and we have a 4 plus I. Well, the conjugate just means change the sign in the middle. So the conjugate would be 4 minus I. And math is fair, so whatever you do to the denominator, you have to do it to the numerator as well. Okay? So we're going to multiply 4 minus I times the numerator and the denominator. And when I distribute 3I inside the parentheses, we get 12I minus 3I squared and if we go by definition, we square A and we square B, and we get 4 squared plus 1 squared. Now let's simplify this a little more, and we have 12I, and instead of writing I squared, remember, replace all I squares with -1. And in the denominator, we have 4 squared, which is 16, plus 1 squared, which is 1, and 16 plus 1 is 17. Okay? And so we have 12I minus, well, not minus anymore, because -3 times -1 is a positive 3 over 17. Now, it's a couple of things wrong with this. One, the imaginary number appears first, and both of the numbers are together. It is very important that we separate the real and the imaginary unit. And so my real would be, in the numerator, the 3 over 17, because this is my real number, 3 over 17, and my imaginary number would be 12 over 17I. And this is our answer. Very important that you separate. After you separate, then you reduce if needed. Now let's do another complex conjugate. Let's say that we have 7 plus 4I divided by 2 minus 5I. And I want to divide these two. But we notice off back that we have an imaginary number in the denominator position. So we're only interested in getting rid of the imaginary unit in the denominator position. So the conjugate would be, you simply change the sign to plus 5I. And remember, in math, math is fair, so whatever we do to the denominator, we also have to do it to the numerator, which is 2 plus 5I. Now we're going to multiply. And remember, I'm going to distribute. So first I'm going to distribute 7. And 7 times 2 is 14. 7 times 5I is 35I. Now we have to distribute 4I. And 4 I times 2 is 8i, and 4i times 5i is 20i squared. And remember, by definition, we square a and add it to b squared, and so we will have 2 squared plus 5 squared. Now don't forget to combine like terms, because in the numerator we have a couple of things going on. And so we're going to have 14 plus 43i plus 20. And remember, all our squares turn to negative ones over 2 squared is 4, 5 squared is 25, and 25 plus 4 is 29. So we simplify a little more, and we get 14 plus 43i minus 20 over 29. In the numerator, we still need to combine like terms, and we have negative 6 plus 43i divided by 29. And remember, the numbers have to be separated, the real on the left and the imaginary on the right. Real before fake. And it'll be negative 6 over 29 plus 43 over 29i. All right, so that is going to conclude one part of section 1.4, complex numbers and conjugates. Let me know if you have any questions. I'm available via text and email. You guys have a great day, and I'll be talking to you soon.